Okay, we're back to the proof of the law of the cosine here. And we're going to go back to our pen tool here, and then we're gonna prove this. This is what we wanna do the proof of. And we already know the answer because we took notes already on the proof. Proof's gonna be a squared is equal to b squared plus c squared minus 2bc cosine of a. And if you're taking the test tomorrow, it would not be a bad idea to memorize this guy. Okay, but I don't like memorizing, and but I find it more challenging if you actually prove it yourself. So that's what we're gonna do. So I set up this triangle for you already, and we know that sine of theta is gonna be h over b. And when we isolate for h, we're gonna get h is equal to b sine of theta. Now let me change this color to a nice little green color. So we have that, and we have cosine. We also have cosine of theta is gonna equal adjacent over hypotenuse. So it's gonna be d over b. And when we solve for d, we're gonna get b cosine of theta. So we're gonna get a situation here where when we look at the blue triangle here, the baby blue. Okay, let's go back to baby blue here. We're gonna get a squared is equal to h squared plus e squared. And when we look at this, we need to isolate for e. So it looks like d plus e is going to equal c. And e is going to equal basic algebra. Subtract d from both sides. We're going to get c minus d. So this information right here is going to go inside here. And the h information is going to go inside here. So we're going to substitute those values as indicated by the arrow, and we're going to get b sine theta plus c minus d theta. Now it's interesting right here too, because we need to substitute the d value here for b cosine theta. So here what we're going to get is a squared is equal to b squared sine square theta plus c minus b cosine theta all squared. Now I'm going to change the color back to yellow again, and then we're going to take care of this guy right over here, okay? We want to save space as much as possible. So let's go ahead and take care of that guy. Okay, going back to our polynomials, we're doing binomial times a binomial where the signs are the same. So let's follow the arrow. Distributive one set, distributive another set. So here we're gonna get c squared. It's gonna be minus bc cosine of theta, and this times this is minus bc cosine of theta plus b squared cosine square theta. So we have two like terms right there. We're gonna underline that, and we're gonna get c squared minus 2bc cosine theta plus b squared cosine square theta. So we have a nice little number here that we got, and this is probably the hardest part, and we're gonna substitute that value for here. We're gonna put it back here because that's what it came down to. So going back to yellow again, we're gonna get a square is gonna equal to b square sine square theta plus all that stuff that we got. As we simplify that, we're gonna get c squared minus 2bc cosine theta plus b squared cosine square theta. Now if you look at it very carefully, we have a nice little term. These two are very nicely coined. And what we could do right there is we're going to look at this right over here. Okay, we're gonna look at this right over here, and we're going to get a square is equal to b square sine square theta plus b square cosine square theta. And if you look at that, okay, because this information hasn't changed yet, so I don't want to repeat it again, but it goes over here, okay? But if you look at this right here, we get, what do we get? We get b squared. When we factor it out, we get cosine square theta plus sine square theta plus cosine square theta. And then we're going to get all of that again here. 2bc cosine theta. Okay, so now this right here cancels out because this is what? That's 1, right? It's 1. So we could put, and let's go back to blue again. We're going to put 1 right there. That's 1. That's the Pythagorean identity, right? That's 1. So we're going to get our final a squared. 1 times b squared is b squared plus c squared minus 2bc cosine theta. Now theta in this case is actually a, big A. This right here, theta is actually big A, right? Because little a is facing the big A. So as you can see, this is the same thing as what's up here. So we just prove the law of cosine, and it's very elegant and is very beautifully done. So I hope that you appreciate my students. I hope that you guys appreciate that law of cosine was actually derived with all the information that you already know, with basic trig function as well as a lot of algebra. Okay, actually I'll say this problem deals with 80% or more with algebra. So again, we see the importance of algebra and just knowing the basic SOHCAHTOA, the trig function. And I hope this video helps, and I hope that you appreciate that what mathematicians have done in order to prove things. So I hope you see you on the next video.